before we do that, we are going to review some important background information. So where we started with looking at graphs is that if we just had 1 point, and 1 point, as we said, is not enough to determine a graph. So if we go look at a quick graph, I'm going to place a point on that graph. So I have the point 0, 1 right here. And if I just place that point, I have a ton of lines I could go through it. So I'm going to place, like, this one goes through it, that one does, that one, this one does, that one does, this one does. So actually, I could put an endless number of lines going through that 1 point. So here I have a bunch of lines that are just going to all be drawn simultaneously. So all these are different lines that could be drawn just through 1 point. So 1 point wasn't enough. So instead of just 1 point, let's go ahead and place 2 points on the graph. So I have 2 points highlighted here. But if we just have 2 points on a graph, that could be connected in many, many, many different ways. So just because we have 2 points on a graph doesn't mean that it's going to be a line. So I have a quick couple examples just to demonstrate that. So here's the point 0, 1 and the point 1, 0. So of course we could draw a line through it. We could draw this thing called a parabola, which is a quadratic relationship. I could put a v through it, which is our absolute value. So the graph could look like that. As we progress forward and learn more functions called trig functions, this is the cosine curve that I could make go through those 2 points. And I know this is not a function, but I could still connect those dots with something like a circle as well. And we're most interested in the line, but just because we have 2 points on a graph does not mean that they are going to be connected by a line. So that's why we looked at different functions. So again, we have like the absolute value. We could connect them like that. We could do stuff like that. And we will study some of these, like our absolute value. This is our quadratics, which we will do in algebra. So once we know that 2 points are going to be connected by a line, that's our permission. We call that a linear relationship. So when we see the words linear relationship, that means we are going to take 2 points and we're giving ourselves permission to connect them with a line and not some other sort of shape. So the first relationship we looked at was that situation, is if we were able to get 2 points on a graph. So here again, I'm going to label 2 points, just any 2 random points that we have on our graph. So there they are. No matter where I put these 2 points, if I have 2 of them and I know that I'm going to connect them with a linear relationship, that's enough to make sure we have our line. So there's a lot of different types of lines. They can look in different ways, but if we have 2 points, we can connect them with a straight line. So we started by looking at standard form. Standard form, right, which was our ax plus by was equal to c. Right, and again, we should know the name. That's standard form. So if we have standard form, we could get 2 points. We could just use the x and the y-intercepts can be our 2 points. And if we have 2 points and we know that it's linear, we simply connect them with a dot. But we also looked at another situation where what if we only had 1 point? What if we weren't able to get those 2 points to connect on a graph, but we did know that it was a line? Now, what we were able to do in this situation is we could say, well, let's just place a starting point. So we could plot a starting point, and then what we could do is we could use the slope of the line, or in other words, like the constant change, to find another point. And then what we would have then, after those 2 steps, we would have 2 points, right? A starting point and another point. So our third step would be connect the dots, which kind of looked like our first situation then. And the first type of line we looked at with that was our slope-intercept form. So y equals mx plus b. Right? And what we said here, this b value, this was our starting point, which was our y-intercept. And then our m value was our slope, or in other words, that constant change that get us to the next point. So just to visualize that, we started with our slope-intercept form. So we would be able to place our y-intercept somewhere on the y-axis, so no matter where we put it, let's put it right around 2. So I'd say this is my starting point, and then I would have to set my slope, so that's I'm sliding here, so maybe it's just 1.2. And as long as I have a y-intercept and a slope, that's enough to make a line. So there's some other points, like this point right here. That point's on the line. I could use all these other things to get more points on a line. So that was our slope-intercept form. Now today, our new form, point-slope form, is that same situation. So I'm going to go ahead and add point-slope form. We're going to write the equation on the next slide. But point-slope form is used for the same situation that slope-intercept form is. We have a starting point that we're going to plot as step number 1. We have a starting point that we're going to plot. We're going to use the slope to get another point, and then we're going to connect the dots. So hopefully you're able to start to see we have a point, right? It's right in the name. And then we also have the slope. Just like over here, how we have a point, just happens to be the y-intercept. And then we also have the slope. So you're going to see that they're very similar. Now, point-slope form of a line is written like this. So make sure you can start to memorize that form. Now, what is it? Well, first of all, there's a couple letters here. So M, the letter M, that's the slope of your line. So that's what the slope in point slope comes from. Now, the point aspect, we're going to notice there's this variable called x1 and this variable called y1. So together, what they do is they make up a point that's on the line. So the x-coordinate of that point is x1, and the y-coordinate of that point is y1. Now there's a few other things to highlight. These have to be negatives. They must be negatives. That's just the rule of the form. We'll look at some specific examples, but that's the way it's written. So one quick example that we would like start with would be something like y minus 3 is equal to 4 times x minus 1. So just so we can start to get our grasp, this is the 4, so that's right in front of the parentheses there. So we know that this is the slope of our line. So in other words, we could say m, which is the abbreviation for slope, is equal to 4. Now to get the point that's on our graph, 1 and 3. So again, we note that it has to be a minus in front of them. So there's a minus sign in front of the 3 and there's a minus sign in front of the 1. So our point that's on the line, the x value of that point is going to be a 1, and then the y value of that point is going to be a 3. So just to visualize before we go graph this, what we're trying to do with point-slope form is we're giving ourselves even an easier time. We can say we can pick any point. It doesn't even have to be the y-intercept anymore. As long as I pick a point anywhere on the graph, so I'm just going to randomly put it right there. If I have a point, and then we have a slope, which I'm setting down here with that slider, if I get a slope, if I combine that information, I'm able to make a line. So I can move this point anywhere, and if I have a slope, I have a line. If I change the slope, I still have a line as long as I have a starting point. So let's do a few more examples just to get introduced to point-slope form. So we're going to start. So let's go ahead and graph a few examples here in point-slope form. and write down a list of steps that we can follow to graph a line given in point-slope form. So the first thing we would want to do when we are graphing point-slope form is we'd want to plot our starting point. So I'm going to write that as plotting the given point. So on this example, what we're looking to see is that we do have the minus signs. That's important in the form, y minus a number, and then x minus a number. So for our point, what number is being subtracted from x? Well, that is the number 6. So that's the x value of our point. And then the number that is being subtracted from y, that is 3. So that is the y value of our point. We can see that, again, in our general form as y minus y1 equals m times x minus x1. So we then can go ahead and plot that point on the graph. So the point 6, 3 is right over here. So our next step then is we've used the point. Now we're going to go ahead and use the information from the slope. So use the slope to plot more points. So in this example, our slope, the number in front of the parentheses, is the number 4. So we will think of that as a fraction, as 4 over 1. So we can see our rise is a positive 4, and our run is a positive 1. So from that starting point, 1, 2, 3, 4 up, and 1 over would be at that point. I can't go up anymore just because of the graph, so I'm going to go down 4, 1, 2, 3, 4, and then left 1, kind of like undoing it. But again, if I thought about moving forward, it's the same thing as going up 4 and over 1. Then, of course, our last step would be to connect the dots with a line. And there we have our first line plotted in point-slope form. Now this next example, what I want to be specific about is that we can see that we don't quite have the general form of point-slope form. So I'm just going to go ahead and write that in the left here in red. Now point-slope form is y minus a number here is equal to m, and then x minus some number there. Now what we like to see it as is y minus y1 equals m times x minus x1. But what we're trying to figure out is what are those coordinates. So what number is being subtracted from y? That's why I've left it blank here. What number is being subtracted from y? And then for the x coordinate, we see it as what number is being subtracted from x. So I just left that blank so I could ask myself what number is being subtracted from x. Now over here I can clearly see that we have a subtraction sign next to x, so the number being subtracted from x is 3. So the coordinate of that point is 3. But what I see on the y side of this is that there isn't a minus sign, it's a plus sign. So with something like this, what we'd want to do is we would need to rewrite the addition as subtraction. And the general idea is if we have like a number plus another number, we can change that to a number minus a negative number. So in this case, I could rewrite our original equation as y minus negative 2 equals 1/2 x minus 3. So when it's rewritten like this, again, I can still clearly see that there is a number being subtracted from x over here, which is why the x coordinate is just a 3, because the number 3 is being subtracted. But now, what number is being subtracted from y? Well, the number that's being subtracted from y is a negative 2. So our y coordinate on this is going to be a negative 2. So when we're graphing these, just pay particular attention. So just like a little note to yourself, which we'll write down here, is watch out for plus signs in point-slope form. Remember, when it's a plus sign, we have to rewrite it addition as a minus minus. So let's go ahead and finish graphing this. So we do know where our point is. Our point is at 3, -2, which is right here. So that was our first step, is plot the given point. The next thing we would do is just identify our slope. And we can see our slope, the number in front of the parentheses, is a 1/2. So that is the slope of our line. It's a positive 1/2. So in other words, my rise is a positive 1, my run is a positive 2. So if I started at my given point of 3, -2, I can go up 1 and then over 2 and get to that point there. Do it again, up 1 and over 2. I'll do some in the opposite direction. Where would I have been if I got here by going up 1 and over 2? Well, I'll go backwards 2 and down 1 then. So I'd be here. So I'll go backwards 2 and down 1. And then our final step is just connecting those all with a straight line as best as we can. And there we have our second graph in point slope form.